we're going to start a very, very brief introduction into light. So I've got a laser there, and I put my hand up, boom. Now, here's the question.
I'm on the pursuit of happiness.
Why can't you see the laser in between the source and the wall?
I can't see
air.
So, obviously, there's a medium in between, right?
Air.
We have air. But the particles, not air molecules, basically the reason that passes through is that the nitrogen and oxygen that make up our atmosphere, when the light travels through it, it doesn't interact with that. Okay? So, now, I put my hand up. Hey, you can see it. Because the structure of the photons and the arrangements that make up my hand, they interact with that light. The same chihuahuas, arrange them differently that make up the oxygen and nitrogen, they pass right through. Now, if I take this can and give it a spray, okay?
Mr. Burkamp, I see the
Then you can see it. So what changes in between? So again, it's a spray. So the particles that make up the spray interact with
the laser.
And now here's what's important. For you to see anything, the light, the photon, has to bounce off those particles and go back to your eye. As it goes through the oxygen and nitrogen, nothing happens. But I put my hand up or I give that a spray, then it interacts with it. Those photons get reflected. They bounce back to your eye. You can see it. So the whole thing, whether or not you can see it, is whether or not those photons interact. Now, what I'm going to do, a couple of different things. So I've got this aluminum foil, and I'm going to shine it through this one over here.
The gold foil.
No, it's not gold foil.
It basically
Right?
it's like when you put a sensor.
So,
that has nothing to do with it.
what this is right here, and you got to make a comparison. So what I did is I took a razor blade and I cut a single very, very small opening in the aluminum foil. So if you notice right here, it's very, very bright in the middle, and then it gets more diffuse. So one of the great debates in science was, what's the nature of light? Is it a wave? Is it a particle? And you can there's arguments for both. Okay, very solid arguments we'll explore. So if light was a particle, imagine that you were shooting like marbles at a solid board, and there was just one opening in the board, and you're shooting marbles at a board. What you would see over here then is just one column of marbles where they would get through. But by virtue of the fact that this spreads out, then it's like, well, maybe it kind of acts like a wave. It's like water wave going through an opening. So you have one wave as it hits that, and then it spreads out, and you get this. Now, the next one I'm going to do is two that are very, very close together. Okay? Now, with this one, you kind of have to get close enough to see this. But with this one, you'll notice what's on this one, there's these very small, what we call like bright spots and dim spots. Okay? Constructive interference and destructive interference. Maximum and minimums. Okay? However you want to describe it. So what you'll notice is that there's regions in here that are very, very bright. This is where these two waves are overlapping. You also have regions that are dark. Okay, the dark regions is what you where you have like that destructive interference, where the waves are canceling each other out. So imagine this. I've got two very small openings in that. So here's that gap. And so what's happening is that since you have two waves coming through there,
Oh,
what happens is that you have regions where they overlap and you get constructive interference, and you have regions where they cancel each other out, and then you get regions of no light. Oh, wow, shouldn't bring so much air. So, if it's a single opening, that light kind of spreads out, which indicates, hey, maybe this stuff is a wave. Certainly, if you have two openings, and you get this constructive and destructive interference where you have bands of very, very bright light and bands of no light, that very much supports the idea that, oh, this thing is a wave, because these waves were interfering as they go through that opening. So, at this point, if you were to ask, hey, what's light? You'd say, that's a wave, because it acts like a wave. It has wave-like particles. Okay, back we go. Tomorrow